Hello guys, welcome to Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this problem from Fundamentals of Physics by Resnick Halliday, chapter 1. The problem says that gold, which has a density of 19.23 gram per cubic centimeter. So we are given the density. The density is 19.32 gram per cubic centimeter, and it is said that gold is the most ductile metal and can be pressed into a thin leaf or drawn out into a long fiber. Now in part A, it is said that if a sample of gold with mass of 27.63 gram is pressed into a leaf of 1.000 micrometer thickness, what is the area of the leaf? So in first part A, it is said that the mass is 27.63 grams and the thickness is 1.000 micrometer, or we can say that this is 1.000 micro is 10 raised to the power minus 6 meters. Now let's say that this is that leaf having mass of 27.63, and the thickness is, let's say that this thickness is 1.000 into 10 raised to the power minus 6 meter, or we can say that 1.000 micrometer. Now the density is given, so we are required to find the area. We are required to find this area for this thin leaf in part A. So the area is required. Now we know that volume is equal to area times thickness. So this area multiplied by the small thickness will give us the volume. Now we can find the volume of this thin leaf since we are given the density. So the density is, we know that the density is mass per unit volume. Now in part A, the mass is given and the thickness is given, and we are asked to find the area, and the volume is again equals to area times T. So we can say that from this we can say that the volume is mass divided by density. So first of all, we will find the volume. Now the mass is given, the mass is 27.63 grams divided by the density, which is 19.32 grams per cubic centimeter. Remember that we are consistent with our units. The mass is in gram, the density is in gram per centimeter cube, so we will get the volume in centimeter cube. Gram will cancel out. So this is we can say that this is 27.63 divided by 19.32. This gives us 1.430. The volume comes out to be equal to 1.430 centimeter cube. Now this is the volume in centimeter cube. Now let's convert this volume into meter cube. So this volume is 1.4. Now we want to convert this into meter cube, so we need to have meter in the numerator and the centimeter in the denominator, since we want to cancel out centimeter. Now we know that 1 meter is 10 raised to the power 2 centimeter. Now we need meter cube, so we will take to the power of 3. So this will be equal to centimeter to the power of 3 and 10 raised to the power 2 to the power of 3, and similarly this. So now this will cancel out. So we are left with 1.430 into 1 to the power 3 meter cube divided by 10, 2 into 3. So this is 10 to the power 6. So this is 1.430 multiplied by 1 to the power 3 is 1 divided by 10 to the power 6. So the volume is equal to, now let's count these number of zeros after the decimal place. This is 1, 2, 3, 4, 5, 6. So this is 1.430 430 into 10 raised to the power minus 6 meter cube, or we can say that this is micrometer cube, but we will use this value. This is 1.430 into 10 to the power minus 6 meter cube is the volume. Now we want to find the thickness. So the volume is again equal to the area times T. So we can equate this into area times T. We want to find the area. So area will be equal to 1.430 into 10 raised to the power minus 6 meter cube divided by thickness. Now the thickness is given in meters as well. This is 1.000 into 10 raised to the power minus 6. So let's put in that value. This is 1.000 into 10 raised to the power minus 6 meters. So 10 raised to the power minus 6 cancel out, 1 meter cancel out. So this we are left with meter square, which is the unit of the area. So this is equal to 1.430 square meters. So this is the area of that leaf. Now in part B, it is said that if instead the gold is drawn out into a cylindrical fiber of radius 2.50 micrometer, what is the length of the fiber? So now let's say that this is that fiber, and let's say that the radius is 2.5 micrometer. Now for part B, the radius is given, which is 2.500 micrometer. We are required to find the length. Now the length is required. Now this is the length. Now this is the length of the fiber which is required, and the radius is given, which is 2.500 micrometer. So now again we know that the volume of this thin fiber will be equal to again this area times this length, and let's say that the volume is again area times that length. And now the area is the area of a circle, which is pi r square. The cross section is circle, right? So this area is pi r square into L. So now we know the volume, since this is that volume, or we can say that this is that volume in SI units. So let me write that the volume is 1.430 into 10 raised to the power minus 6 meter cube. Now that same mass and that same volume is now drawn into a thin fiber, right? Since we are using the volume of that particular mass and with that density. So this is constant for both the leaf and for the fiber. So now the volume, we know the volume, which is 1.430 into 10 to the power minus 6 meter cube. And now again the volume is pi r square. This will be equal to pi r square into L. Now we want to find the length, so that will be equal to 1.430 into 10 raised to the power minus 6 meter cube divided by pi r square. Now in part B we are given the radius, which is 2.500 into 10 raised to the power minus 6 micro is 10 raised to the power minus 6 meter. So now let's plug in this value into this, and we will be able to find the length. So now the length will be equal to 1.430 into 10 raised to the power minus 6 meter cube divided by pi, and the radius is 2.500 into 10 raised to the power minus 6 meter to the power 2. So now again we are consistent with our unit. This is in meters and this is in meters. If the radius is given in some other units, then we need to convert them into meters. So now this will be, if we apply the square, this will become square and this will become meter square. So let me write this as like this, and this will become meter square. So this is 1.430 into 10 to the power minus 6 divided by pi multiply by 2.500 multiply by 10 to the power minus 6 to the power 2. So this gives us length 72829.302 approximately. And again, as we can see that this is meter square, so meter square will cancel out meter square, so we'll be left with only 1 meter. So the length will come out to be in meters. And now the length is 7229.302 meters, and if you want to convert this into kilometer, so length is 72829.302. Now we want to convert this into kilometer, so kilometer need to be in the numerator, so 1 kilometer is equal to 1000 meters. So we need to divide our answer by 1000, so that will give us 72.829. so this is 72.829 kilometer. So now this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy and let me know in the comments if this helps in your learning.